Yes, today we're going to use the derivative to find the critical points where the graph is increasing, decreasing, your local maximum, local minimum, the inflection point, and your concavity, where it's going up or down. First, what we need to do is take the first derivative and second derivative. That's the first thing we want to do. So this will be f prime of x, and it's going to be, the first one is going to be 6x squared minus 6x minus 12, and the derivative of constant is just a 0. Then we're going to take the second derivative. Okay, we need to take the first and second derivative. That's the first thing we want to do. And it's going to be 12x minus 6. And what we want to do is we want to set our first derivative that we got, right? Prime of x. We're going to set it equal to 0. So we have 6x squared minus 6x minus 12 is equal to 0. And what we could do, we could divide everything by 6, by 6, by 6, and by 6. Everything by 6. This will cancel this. This will cancel this. And this will be a 2 right here. And what we're going to have is x squared minus x minus 2 is equal to 0. And we can factor this into x minus 2 and x plus 1 equals to 0. So then my critical points are going to be x is equal to 2 and x is equal to minus 1. And when you have your two critical points, we're going to put it over here. This is going to be, I'm going to put here a 2 and a minus 1. And what we're going to do is we're going to get a number before and after. Well, before -1, we can use -2. After, we can use the 0. And after the 2, we can use a 3. And now what we're going to find out is, you see how I factor this right here? X minus 2 and x plus 2. Just go ahead and put it right here. X minus 2. Okay. X plus 1. And the same thing. X minus 2. X plus 1. And here again, x minus 2 and x plus 1. And we're going to get this number right here before the -2, and we're going to place it in here. Well, this is going to be -4, and this is going to be a 1. If we put a negative here, we're going to get that this is going to be -1 times -1 times -4. This side right here is going to be positive. If we put a 0 here and a 0 in this x, this side is going to be negative. And if we put a 3 here and a 3 here, this side is going to be positive. So right away I know that my graph is going to be increasing from positive, and a negative is going to be decreasing, and then it's going to go increasing again, positive again. And what do I know? I know that it's going to be increasing from negative infinity to what? To -1, right? Then it's going to be decreasing from -1 to 2, and it's going to be again increasing from 2 to infinity. Okay, so it's going to be increasing here, going to be decreasing here, and it's going to be increasing again in here. So now what we want to do is we got our 2 and our negative, our critical points. So if we go ahead and we place our critical points back into the equation, into this function right here, right? If we do that, we're going to get that, let's say that f of -1 is equal to 2 times -1 to the third minus 3 times -1 to the second minus 12 times -1 plus 6. And this is going to be equal to, when we solve this right here, this is going to be equal to 13. Okay, so when it's -1, a -1, my y value is going to be 13. Now we could do it for f of 2. And this is going to be 2 times 2 to the third minus 3 times 2 to the second minus 12 times 2 plus 6. And this is going to be equal to, this is going to give me -14. So at 2, it's going to be -14. So I can just come over here and say, okay, a -1, this is going to be -13. Somewhere down here. Point here is -1, comma 13. Okay? And at 2 is going to be down here, somewhere down here. So at 2, it's going to be -14. So now, what we need to find is now our maximum and our minimum. Okay? Sorry, no. This 1, we got 13 right here. Sorry, 1, my point is 1, -1. When it's -1, I get 13. Okay, so I know how my graph is going to go already. If I set my equation to 0, everything x here, if I put a 0 here, and a 0 here, and a 0 here, it's going to be 6. So my y-intercept is going to be at 6. I know that when x is 0, y is 6. I know that much. So now I know that my graph is going to go like this. Let's go, we could do something now. I got my second derivative. We could find, okay, I got my second derivative right here, which was my f double prime of x was equal to 12x minus 6. I'm going to set it to 0. So 12x minus 6 is equal to 0. So my x is going to be equal to 1/2. I know that somewhere around here, my x is going to be 1/2. Now, how can I find my my y value for that point? Well, I'm just going to go ahead and put it back into this the main function. I'm just going to say 2 to the 1/2 to the third minus 3 to the 1/2 to the second minus 12 to the 1/2 plus 6. So this is going to be 1/8 times 2. This is going to be 1/4. And this is going to be minus 3/4, I'm sorry, minus 3/4. This is going to be negative 6 plus 6, that's going to be 0, so then I'm going to get negative 1/2. So now I have that my inflection point, okay, my inflection point, okay, is 1/2, and my y value is going to be negative 1/2. And now I'm going to come over here and I'm going to place my inflection point 1/2, and I'm going to get, from here I'm going to get 1 before, a 0 and a 1. And I'm going to determine what the concavity is. Okay? So how do I do this? Well, I'm just going to go ahead and put this value, right, into my second derivative, right? If I put a 0 here, I'm going to get a negative 6. It's going to, so this is negative. The side here is negative. And if I put 2 here, it's going to be positive. It's going to be 24 minus 6. It's going to be positive. So I already know that my concavity in this area right here is going to go like this. And in here, it's going to go up positive like this. And the inflection point is at 1/2. So this is 1/2, and I'm going to go negative 1/2 right here. Okay? So I know that my graph is going to come this way like this, from infinity, from negative infinity. Okay, this is going to be negative 1 right here. This is minus 1 right here. Okay, and this right here is my 2. So it's going to come here from infinity, right? It's going to be coming like this. Sorry for the graph. It's going to cross through here. It's going to continue going up, 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 up. It's going to come down. It's going to cross my x-axis right here at 6. It's going to continue down onto my inflection point. That's where the graph is going to concave now up. And it's going to go down like this. I'm trying to do the best I can. It's going to go down like this, and it's just going to go back to infinity like that. So from here it comes from negative infinity, increasing from negative infinity to minus 1, right? Then it's going to be decreasing from where? It's going to be decreasing from minus 1 to 2. And then it's going to be increasing again from 2 to infinity. And this is how you can determine the critical points, whether it's increasing, decreasing, your local maximal. This will be your local maximal right here. This will be your local minimal right here at the bottom. The inflection point is 1/2. It's going to be 1/2, okay, and negative 1/2. It's going to be here. Sorry for the graph. I mean, I'm trying to do the best I can. Then your concavity, you could see that, like we have here in the first quadrant, it's going to be sort of negative, see, going down, and it's going to change at this point right here, a negative 1/2 and negative 1/2 is going to concave back up. That's why I have it over here. You see here, this right here, it's letting you know how the graph is going to be concave down in one side and concave up in the other one. So if you like this video, please hit like and subscribe. Thank you.